So we'll work through an example to show how to calculate our correlation value if we were given some data. So what I've done is collected the heights and weights of 6 individuals which I have here. So again we have our formula which gives us our correlation by summing from I equals 1 to n, xi minus the mean of x multiplied by yi minus the mean of y, all divided by n minus 1 multiplied by sx and sy. So there are a few things that we need to calculate first, which are our mean and standard deviation values. First we'll find the mean of our height values. So we have our formula which reads as the sum from I equals 1 to n of xi divided by n. All this means is that we add all our height values together and divide by the number of observations. So here we have all our collected height values added together and divided by 6, which is the number of observations we have, to give a mean height value of 67.5 inches. Next we need to find the mean of our weight values. So again we have our formula which reads as the sum from I equals 1 to n of yi divided by n. So here we have our collected weight values added together and divided by 6 to give us a mean weight value of 119.83 pounds. Next we need to find the standard deviation of our height values, and our formula for this reads as the square root of the sum from I equals 1 to n of xi minus x bar squared divided by n minus 1. So our calculation will look like this, where we subtract our mean height value from our first observation and square it, add it to our second observation minus our mean height value, all to be squared, all the way up to our last observation. Divide all this by 6 minus 1 and we find the square root of our answer. This gives us a standard deviation of 5.17 inches. Next we find the standard deviation of weight using the same formula as above. So for this we subtract our mean weight value from our first observation and square it, add to our second observation minus our mean weight value, all to be squared, and continue all the way up to our sixth and last observation. This is then divided by 6 minus 1 and we square root our answer to get a standard deviation of 19.08 pounds. So what I'll do is work through the top and bottom lines separately just to make the calculations a bit easier to understand. So our top line looks like this and reads as the sum from I equals 1 to n of xi minus x bar multiplied by yi minus y bar. So what we do is we take our first person's height and subtract our mean height, take our first person's weight and subtract the mean weight, and multiply the two together. We do the same for the second individual and so on until we reach our last subject. We add all these together and get a value of 448.5. Now we have the top line of our equation worked out. Next we'll work out our bottom line, which reads as n minus 1 multiplied by the standard deviation of variable x by the standard deviation of variable y. So when we fill our values in, we have 6 minus 1 multiplied by 5.17 multiplied by 19.08, which gives us 493.218. Now that we have our top and bottom values, we can work out our correlation value by dividing the top by the bottom to get a correlation value of 0.910. What this tells us is that there is a strong positive linear relationship between height and weight. Some things to note about correlation is that if we are given the standardized values and asked to calculate their correlation value, we must remember that the standardized values have a mean of 0 and a variance of 1. This means that our correlation formula will now be the sum from I equals 1 to n of xi multiplied by yi, all divided by n minus 1. The next thing to note is that correlation does not imply causation. An example that you may come across in class is a study in which the number of cavities a school child had and their vocabulary size were highly correlated. Having a high correlation does not mean that by eating more sweets that a child will be smarter. They are highly correlated because the number of cavities and vocabulary size exhibit a common response to the age of the child. The last thing to note is that if we change the units our data was recorded in, it does not affect the correlation value. For example, if our data was recorded in minutes and we converted our data to hours, then our correlation value would not change. The development of these resources was supported by the NDLR and the Department of Mathematics and Statistics at NUI Maynooth, and they will be available from the following websites.